Hello, and welcome to Patch Math, where today we'll be solving a system of linear equations using the substitution method. So, when is the substitution method best applied? And that is going to be when at least one of our equations is solved for one of the variables. Now, in this example, you will see immediately we have that set up. Our first equation has been solved there for y. All right. So just like the method sounds like, we will be taking all that y equals, and we will be taking it and plugging it in for where y is in the second equation. Now you're going to want to make sure you put parentheses around this when you substitute it. So I'm just going to go ahead and write out the second equation, but leave a spot open there for y to plug it in terms of x. And I like to color code, and you're going to see right where y was in the second equation. We're going to plug in parentheses 6x minus 11. The reason we use parentheses is we want to make sure all that y is gets multiplied by that -3 that was out in front of y. And because y equals two terms, we have to have that parentheses to ensure both of those terms get multiplied by that -3, otherwise known as distribution there. So that will be our first step in simplifying the left-hand side of this equation. We are distributing the -3 into the 6x to start with. And -3 times 6x is minus 18x. Then we will be distributing that -3 into that -11. And a negative times a negative is a positive number. And 3 times 11 turns into 33. We have a single equation in terms of x, so we can solve for that x. But notice our x is occurring in more than one spot. And so anytime an x occurs in more than one spot, we want to combine those like terms. All right. And that gives us negative 20x, because -2 minus 18 is -20, plus 33 equals -7. Now, no more simplifying can be done. We can launch into the solving phase. We solve by doing the opposite operation of how the numbers are attached to x on both sides of the equal sign. Now, because we're doing opposite operation, we will do opposite order of operations to guide us. Many of you all know that PEMDAS or GEMDAS to be our acronym here. And so we'll be doing opposite PEMDAS or opposite GEMDAS, meaning if there's addition or subtraction, we must undo it first. In this case, we have 33 being added on, and we can subtract 33 equally on both sides of the equal sign, canceling it out. All right, that leaves that -20 untouched on that x. We will deal with it in a moment, and we find that -7 minus 33 is 40. Excuse me, -40. And then now all we look at how is that -20 is attached to that x. The operation, whether we can see it here or not, is multiplication. So we will be undoing multiplication. The opposite of multiplying is division, so we'll be dividing off -20 on each side. -20 divided by -20 is 1, leaving us with 1 times x on that side, in other words, just x. And then -40 divided by -20 is 2. If you will recall, a solution to a system is the point of intersection of the two lines. And that point of intersection is an ordered pair with an x and a y. We have found our x. Now we need to find the y that goes with it. If you will recall, what our equation solved for y is the first one. I'm going to go ahead and bring it on down. And now we're just doing substitution in a slightly different way. We are taking all that x equaled here and plugging it in for x down here. That happens to be a lot simpler than what we just did. Y equals 6 times that x minus 11. That x is equal to 2. We know that 6 times 2 is equal to 12. And 12 minus 11 is equal to 1. And so y equals 1 there. And our complete ordered pair, our solution to this system, is that x, comma, that y. And since up till now, you have probably been used to seeing systems and their solutions via graphing. Here is the graph of both of those equations, and you'll see they intersect at 2, 1. And the source that I used to graph these is desmos.com. So I'll drop that link in the description below this video. All right. Thank you so much for your time.